So our next question is, check the continuity of the following function at x equals to 2. So here we have to find the continuity. So we will use the rule for the left hand limit and the right hand limit. So the left will be the negative, okay. At 2 it is asked in the question. So solution, left hand limit will be limit x extends to 2 negative, okay. So it for x that is equal to negative in the sense x is less than 2, right? So here first condition is x is greater than 0 and less than 2. The function will be 1 by 2 into x square minus 4. When x is equals to 2, the function is equal to 0, and when x is greater than 2, the function is 2 minus 8 x power minus 3. So here it is the less condition, so the function is this. So it is limit x extends to 2 negative will be half into x square minus 4. Now we will substitute x as minus 2. So the function becomes 1 by 2 into minus 2 square minus 4. So this will be equal to 1 by 2. 2 minus 2 square is 4 minus 4, which is equals to 0. 0 into half is also 0. So we have got the left hand limit as limit x extends to 2 negative f of x is equals to 0. Now we will solve for the right hand limit, which is greater than 2. Okay, if we get the same answer as 0, then they are continuous, or else they are not continuous. So right hand limit will be x limit x extends to 2 positive x f of x. So it is 2 positive means x is greater than 2. So greater than 2, the function is this. I'll write here limit x extends to 2 positive. The function is 2 minus 8 into x power minus 3. Okay, so it will become limit x extends to 2 positive, 2 minus 8. Here x power minus 3 can be written as 1 by x power 3. Now substituting x as 2, we will get 2 minus 8 by 2 cubes. So it will be 2 minus 8 by 8. 2 cubes is 8. So it is 8 ones cancel out. So 2 minus 1 is equals to 1. So we have got the right hand limit as limit x extends to 2 positive f of x is equals to 1. When we have solved the left hand limit, we got it as 0, and for the right hand limit we have got 1. So they are not equal, right? So it is not continuous. This function is not continuous when x is equals to 2. So we have to write as limit extends to 2 negative f of x is not equal to limit x extends to 2 positive into f of x. Okay, but there is one condition here, that is limit x extends to 2 negative f of x is equals to 0, which is equals to the function when x equals to 2. X equals to 2, we have got the value as 0, right, in this case. So it is left continuous. Therefore f is only left continuous at x equals to 2. So our next question is, if f given f of x is equals to k square into x minus k, if x is greater than or equal to 1, and this function is equals to 2 when x is less than 1, is a continuous function on R, then find the value of k. So it is already given that it is a continuous function. So here the left hand limit function is equal to the right hand limit function. So solution, left hand limit will be, here the x value will be 1. Okay, so limit x extends to 1 negative f of x, which will be equal to nothing but, it is 1 negative means x is less than 1, right? Less than 1. Less than 1 condition is 2. So this function is equal to 2. Next, right hand limit. So limit x tends to 1 positive into f of x is equals to limit x extends to 1 positive. Here is the condition x is greater than 1. Greater than 1, this is our function k square x minus k. Okay, now substituting the value of x as 1 in this equation, so it is k square into 1 minus k, which will be equal to k square minus k. Now we have to find the value of k. So it is given, it is a continuous function, so we can equate this to limits, right? Given that f of x is continuous on R, so limit x extends to 1 positive, f of x is equals to limit x extends to 1 negative, f of x. So the positive value is k square minus k is equal to the negative value is equals to 2. Bringing the 2 here, so it is minus 2 equal to 0. Factorizing it, so 2 ones are 2, so we can write it as k square minus 2k plus k minus 2 equal to 0. Factorization, okay. Taking k common here, so it will be k minus 2 will be left. Same factor you have to write here. We have the same factor here, so it is plus 1, so equals to 0. So it is k plus 1 is one factor, another factor is k minus 2 equals to 0. So here we'll get k as the negative 1 and k as the positive 2. So the value of k is minus 1 or 2. Our next question is find real constants a and b so that the function f given by f of x is equals to sin x if x is less than or equal to 0, x square plus a if x is greater than 0 and less than 1, and bx plus 3 if x is, here the condition is less than or equal to 1 and greater than or equal to 3, and minus 3 when the function x is greater than 3. Okay, so we have to find, and it is continuous at r is a real number, right? So here we have to find the value of a and b, and the function lies from the conditions of 0, 1 and 3. Okay, so you can solve any two of the conditions either for 0 or 1 or 0 or 3. Okay, so you will get the values of a and b. So here it is continuous, so the left hand limit is equals to the right hand limit. Okay, first I'll solve for the 0. So left hand limit x extends to 0 negative of the function f of x. 0 negative means x is less than 0. So here is the condition, x is less than or equal to 0. The function is sin x. So this can be written as limit x extends to 0 negative sin x. So substituting the value of x as 0, so it is sin 0. Sin 0 is equal to 0. Now solving the right hand limit, so it is limit x extends to 0 positive into f of x. So here the function x will be greater than 0. For greater than 0, here is the condition, x is greater than 0 and less than 1. So this is our function, so it is limit x extends to 0 positive. Our function is x square plus a. Now substituting the value of x as 0, so it is 0 square plus a will be equal to a. Now it is already continuous, so we can equate this to limits, right? F of x is continuous on R, so the left hand limit is equals to the right hand limit. So the value of left is 0, 0 is equals to a. So from here we can say that a is equal to 0. We got the value of a. Okay, similarly you have to solve for 1. Okay, f of x is continuous at x equals to 1. So it will be left hand limit x extends to 1 negative of the function f of x. Here 1 negative is x is less than 1. So here we have to again check our condition. Here is the condition. So our condition is x is greater than 0 and less than 1. So this is our function. So we'll write limit x tends to 1 negative x square plus a. So it will be here minus 1 square plus a. So it will be minus 1 square is 1 plus a. So here we can substitute the value of a as 0. So it will be 1 plus 0, that is equal to 1. Okay, now solving for the right hand limit. Limit x tends to 1 positive f of x is greater than 1. So the function for greater than 1 of x. So here it is, x is greater than or equal to 1, right, and less than or equal to 3. So this will our function bx plus 3. So we'll substitute here limit x tends to 1 positive bx plus 3. So this can be written as substituting the value of x as 1 here. So b into 1 plus 3 will be b plus 3. Now we know that it is continuous. So the limit, left hand limit will be equal to the right hand limit. So the left value is 1. 1 is equal to b plus 3. Shifting this 3 to that side, so it will be b is equal to minus 3 plus 1. So b is equal to minus 2. Therefore, the value of a is equals to 0 and b is equals to minus 2.